Hello students, I am Professor Dash. Today's topic is K-map. Already in previous class I already discussed how to do a K-map using mean terms or soft form. What is soft form, what is pause form. So I already discussed in part 1 about all these topics. Today we'll discuss how to do a K-map using pause form or maxterm using maxterm. Basically the procedure is same, just the representation is little bit different. Okay, so first take an example, that is the problem is reduce the following function using K-map, and the function is y abcd pi m 0289 12 13 15. So from this expression we can know, we can see that this expression denote the pause form, because here is the pi sign and capital M, and the position indicates the max term. So first of all, here we use four variables A, B, C, D. So the cell number will be 16. Suppose here it is not given, that is suppose the question is y equals to then these positions, then how you can calculate the number of variables. First consider the maximum number. Number means maximum position number. Here it is given 15. So to represent the number 15, minimum number of variable required is 4, because 15 can be represented by 1 1 1 1. So 4 variable is required. So in this way we can identify how much variables will be used in this K-map. Okay, so here four variable is used. So first draw the table of the K-map. Here I take AB and here I take CD. Similarly, first column denote 0 0, then 0 1, then 1 1, after that 1 0. But here there is a little bit different from previous K-map. Here we will use the max term. So in case of max term, we already discussed that the variable itself defined as 0 and the complement of the variable is defined as 1. So and max term means the product of sum. Each term is a summation. So here this first column 0 0 indicates by A plus B. A plus B, it is a summation term, and 0 indicates by A and 0 indicates by B, because in case of max term 0 means the variable, 1 means the complement of the variable, and as it is we use max term here, so the terms indicate by summation. So here it is written A plus B. After that 0 1, so 0 means A, 1 means B bar, so here it is written A plus B bar. After that 1 1 1 1, so we write A bar plus B bar and then A bar plus B for 1 0. Okay, similarly in this side 0 0, that is C plus D, 0 1, that is C plus D bar, 1 1, that is C plus D bar, sorry, C bar plus D bar, 1 0, that is C bar plus D. So it is the difference of the representations. In case of mean term, here we will use the product terms, but in case of max term we will use the summation terms. In case of mean term, 0 indicate by the complement, 1 complement bar, and 1 indicate by the 0 indicate as a variable complement and 1 indicate as a variable itself. But in this case, that is for max term, 0 indicate the variable and 1 indicates the complement of the variable. Then denote the position similar way. I write down the positions, that is 0 1 2 3 4 5 7 8 6 7 12 13 15 14 8 9 11 10, like the previous one. Okay, now Here it is given that the positions are 0, 2, 8, 9, 12, 13, 15. So I put 0 on this given positions because it is indicate the max term. In case of min term we use 1, but in case of max term we will use 0, and rest of the positions indicate 1, but we don't write 1, only just write down the zeros and consider the zeros. Then the procedure is same. First, group of 8 adjacent cells, that is octal. If it is not possible, then consider 4 adjacent cell, that is quad. If it is not possible, then consider 2 adjacent cell, that is pair, and after that take singles. Similarly here I take first of all this 4 zeros, these 4 zeros as a octal, sorry, as a quad, and this two side, as it is the both 0 are placed in the corner of a same column, so we take these two as a pair, and this 2 0 will take as a pair. So here we'll get three terms. One is quad, another one is pair, and third one is also a pair. Now what will be the output? First of all, for this quad section. Similarly, first of all, for these two column, which term is common? A bar is common. Okay, for these two column. And for these two row, which term is common? C is common. So the answer will be A bar plus C. In previous example, in case of soft terms, we'll write each terms like a product. But here we'll write down these terms as a summation. So we write A bar plus C. Then for this pair, the common terms is A bar plus B bar, and similarly row wise the common term is D bar. So we'll write A bar plus B bar plus D bar. Then for this pair, the common term is A plus B, and for this two row the common term is D. So the uh, so the summation term is A plus B plus D, and all these three summations is connected through a AND operation. So it is looks like a POS form, that is the product of sum form. It is not the standardized POS. It is looks like a POS form, and it is a final answer. So in this way we can use the mean terms for simplification using K-map. Now another example. What is the question? Reduce the following function using K-map, and here it is given y equals to some positions value. So here we can see that there is no variable indicate. So from this question we can identify 13 is the maximum number. So to represent the 13 we need at least 4 variables, because 1 1 0 1 equals to 13. So to design this K map we need 4 variables. I take this A B C D. You can take any alphanumeric variables A B C D E F G H, whatever. I take here A B C D. And similarly first represent the table 0 0 0 1 1 1 1 0, and here 0 means same the variable, 1 means the complement of the variable, and as the question is using the max term, so here all the terms will be in summation terms. So here it is written A plus B, then A plus B bar, then A bar plus B bar, then A bar plus B. Similarly here C plus D, C plus D bar, C bar plus D bar, C bar plus D. And then uh, on these positions which is given in the questions, I put 0 because it indicates the max term. Okay, then similar process, first we'll try to take octal, then quad, then pair, then single. Here we can see that this 4 0 and this 4 0, we can make this 8 0 as a octal because all are the corner sides of same row. So we can take this 4 and this 4 to make a octal. Then these 2 0 are remaining, so we take this 4 0 as a quad. Okay, so what will be the output for this octal? A plus B, here it is written A bar plus B, so B is common, and for this 4 row there is no common variable, so the resultant will be only B. Now for this quad part, here it is written A bar plus B bar, here it is written A bar plus B, so A bar is common. And for this 2 row, C bar plus D, here it is written C plus D bar, so C is common. So we can say that the representation of this quad is A bar plus C. So it is the final output. Okay. Now another example, suppose in previous problems the positions is given, but suppose in this question the expression is given. What is the question? Minimize the following Boolean expression using K-map. Y ABC equals to AB plus CB bar plus C. Okay. So first of all, we should know the positions because otherwise we cannot put the values 1 or 0. Okay. So first of all, it looks like a soft form, but it's not the standardized soft form. So first of all, to standard soft form, to get the standard soft form, we should apply some rules or laws. What is this? First, in this product term, C is missing, then A is missing, after that AB is missing. So in first term, AB dot 1, in place of 1 we can replace by C plus C bar. After that A is missing, so we can write that 1 dot B bar C, or in place of 1 we can write A plus A bar. Similarly, in third place, A and B is missing, so I write here A plus A bar into B plus B bar into C, because A plus A bar equals to 1, B plus B bar equals to 1, and 1 dot 1 dot C equals to C. Now simple multiplications, we get this product terms after simple multiplications. If any term is more than one time, then we'll write this term only one time. Okay, so after that we will get this expression. This is the standard soft form, we can say, and from this expression we can get the positions or the mean terms value. So what are the values? A, B, C, so we can write 1 1 1, that is same 7. A, B, C bar, that is 1 1 0, that is same 6. How you can get it? Because as it is the soft form or mean term, so the variable means the 1 and complement of the variable means the 0. So A, B, C, so we can write 1 1 1 and its equivalent value is 7. So we write M7, small m7, because it indicates the mean term. A, B, C bar 1 1 0, A, B bar C 1 0 1, A bar B bar C, that is 0 0 1, A bar B C 0 1 1, and so on. We get the positions, that is summation M, that is indicate the soft form and mean terms, and the positions are 1 3 5 6 7. So from this expression we can see that here we use three variables, so the cell numbers will be 8, and first we design the table. I take AB in this side and C in this side. So as there is two variables, so row wise there will be four representations: 0 0 0 1 1 1 and 1 0. After that in this column wise one variable, so the representations will be 0 and 1, and then write down the positions 0 1 2 3 4 5 6 7, and after that put the value 1 in this given positions. Okay, then we'll solve the problem. Here we will take a quad 1375. Using these positions we will take a quad, and this will be a pair, and the output will be for this quad, the output is C, and for this pair the output will be AB. So it is the final answer. Okay, so if the in this problem the positions are given, so first you think it is min term or max term. According to this expression we will put 0 or 1 uh, on this but given positions. But if there is a expressions, then first of all standardize the expression. After that, from this expression we will get the positions value of min terms or max term. Then draw the tables and put the values depending on the questions. Now another example, it is written that minimize the following Boolean expression using K-map. So from this expression we can see that it is a POS form but not standardized POS form, because in first term D is missing, in second term C is missing. So first of all we should standardize the expression so that we can get the positions value of the max term. How we can do this? First of all, in first position D is missing, so we can write A plus B plus C plus D dot D bar, because D dot D bar equals to 0. After that, in second terms, as C is missing, so we use C dot C bar, and then we will use the formula, that is x plus yz equals to x plus y into x plus z. Use this formula in this portion, so we can write this A plus B plus D into A plus B plus C plus D bar into A bar plus B plus C plus D, A bar plus B plus C bar plus D. And similarly, if one term is more than one time, then we will write only one time of this particular term. And as it is a POS form, so or we can say as it is a max term, so the variable indicates 0 and complement of the variable indicates 1. So here A plus B plus C plus D, so all variables are 0 0 0 0 and indicates M0. This M is capital letter because it's indicate the max term. And in this way we will get M0, M1, M8, M10, and this is the expression pi m0180. So first standardize the expression, and after that this from this expression we will put down the value 0 of this given position, that is 0180, and then we will do the K-map. Here we will get a pair using this 20 and another pair using this 20, that is the position 8 and 10. Okay, and this is the final expression. As it is the max term, so the expression is looks like the POS form, that is for first pair we'll get A plus B plus C, and for this pair we'll get A bar plus B plus D. This is the final result. Okay, now another topic related to K-map, that is the don't care condition. What is this? Basically, when the Boolean function is defined in terms of min terms, ones are entered in the K-map corresponding to the input conditions, and when the Boolean function is defined in terms of max term, 0 are entered, and the cells that do not contain 1 are assumed to count 0 and vice versa. This is not always true, because some in such cases the output label is not defined. It can be either high or low, but we cannot define it. This output is called don't care, which is indicated by small d or cross sign. The symbol is small d or cross sign. We can define this symbol as a don't care condition. So we can take this don't care as 1 as well as 0. So we can say that this don't care in a cell may be assumed to be 1 or 0 depending upon which one leads to a simple expressions. Okay, now we take an example, that is the question is simplify the following boolean expression y equals to summation m 1 3 7 11 15 plus d 0 to 5. First of all, what is denoted by this expression? First of all, there is the summation sign, so it's related to mean terms. Second of all, d small d, then 0 to 5. So when we make the tables in the position 0, 2 and 5, we'll put the don't care. That is, we'll write down either small d or cross sign. And in this position 1 3 7 11 15, we will put the 1 because it is the mean terms, and as it looks like a soft form, so here it is written looks like that. This is summation m 1 3 7 11 15 plus don't care 0 to 5. If it is related to pause, then we will write dot here in place of plus, but as it is plus, so it indicates the soft form or the mean terms. Okay, now how much variable is required? From this expression, the maximum position is 15. So 15 can be represented by 4 variables because 1 1 1 1 equals to 15. So as 4 variable is required, so here first draw the table using the 4 variables and represent the tables for 0 0 0 1 1 1 1 0. Similarly here 0 0 0 1 1 1 1 0. I take a b c d as a variable. After that, put the positions number 0 1 2 3 4 5 6 7 so on. Now the position 1 3 7 11 15, put the value 1 in this position 1 3 7 11 and 15, and put don't care in this position 0 to 5. So here 0 to 5, I write cross sign indicate as a don't care. You can write small letter d in place of don't care also. Okay, now basically, rules is same. First take octal, then quad, then pair, then single, but all one must be used. But it is not necessary that all the don't care will be used. If to group a octal quad pair, uh, if it is necessary to take a don't care, you can consider this don't care as a one, otherwise just ignore it. Okay, first of all, from this problem we can show that we can take this 4 1 as a quad. Fine, then this one also left. So if we consider this don't care, that is placed in position 5 as a 1, then we can take this 4 1 as a don't care. Again I repeat, first of all I take this 4 1 as a quad. After that, this one is left till now. So if we consider this don't care which is placed in place 5, then using this 4 1 we can make a quad also. So I take this don't care as a 1. I consider this don't care as a 1. Now all the don't care, all the ones already used, so here this don't care and this don't care, we just ignore this don't care, that is we don't consider this don't care as a 1. Okay, just take this don't care to make the quad. Now what is the result for this quad? The output will be cb cd, and for this quad the output will be a bar d. Okay, this is the final result. Now, one thing I will say that maybe some of your friend use this don't care and this don't care as one and make this 4 1 as a quad. Yes, it is correct. At this time, you ignore this don't care. Okay, again I repeat, maybe some of your friend use this don't care and this don't care as a one and make this for one as a quad, then it is also correct. And at this moment, just ignore this don't care. Okay, now take another example. It is simplify the following Boolean expression. The expression is given here. So from this expression we can see that it is a pos form or mean terms because there is written pi sign, and similarly use 0 at this positions 4, 5, 6, 7, 8, 12 as it is indicate the max term, and here it is given don't care. So at this position 1, 2, 3, 9, 11, 14 we will put don't care, that is cross sign or small d, and as it is the pos form, so here it is written dot, but in previous problem we write there plus. Now the maximum position in this problem is 14. So 14, how we can write 14? That is 1 1 1 0. So similarly the minimum number of variable is required 4. So first draw the table using 4 variables, then put the values as it is the max term, so put 0 in this position and then don't care of the given problems. Okay, then first target is to consider the all the zeros. Okay, in this problem we can take this 4 0 as a quad and this 2 0 as a pair. In this problem we can consider this 4 0 as a quad and this 2 0 as a pair. Okay, so we can say that all 0 are already used. So in this particular problem we don't use any one don't care, any don't care is not to use, because without using the don't care all the 0 can be considered. So here you can ignore all the don't cares. Okay, suppose uh, suppose in this position, suppose position number 13 there is a don't care, suppose, then you must consider this 9 and 13, these two don't care to make a octal. Okay, again I repeat, in this particular problem already all the 0 are used, so we ignore the don't care. But if in 13 position if there is a don't care, then we cannot ignore the don't cares, because if there is a don't care in 13 position, then we can take this 2 0 and this 2 don't care as a quad. So in that particular problem we must use these two don't care to make a group of 4 adjacent cell. But in this problem we it is not necessary to use the don't care, and this is the output y equals to a plus b bar for the quad and a bar plus c plus d for the pair. So in this way we can solve any types of K-map using 2 variable, 3 variable, 4 variable, whatever. We can use mean terms as well as the max term, and we can use the don't care condition also in this K-map. So this is the gist of doing K-map, which is used to minimize a Boolean function. Thank you.